Friends, colleagues and listeners, lovely to see you all again, or for you all to hear us again, whichever it may be. And we're still here in Seville, beautiful city, and we're at the GSE conference. The person I've got with me today is somebody, and I think everybody will know what I mean when they see his picture or they see him on the camera. When you walk into a room, certain people leap out. No matter how big the room is, and they leap out at you for many a reason. I'm not suggesting this is the only reason why the next guest leaps out, but my guest is Edward Victor Alves. He's the sales director of Sinepower, and my God, you've got an absolute beautiful royal beard. And I say royal, it's magnificent. I cannot imagine the amount of time and care that's gone into that, but it is, honestly, God, I would give anything to be able to grow a beard like that.
Thank you very much.
All right, so you look fantastic, my friend. Brilliant.
Thank you very much. 12 years in the making, so
really?
There you go. Yeah.
But it's superb. It's a work of art.
Thank you very much.
It's
a good sales point as well, man.
Yeah. No, it is. It's good. Right. Firstly, thanks for joining us. Secondly, Sinepower. So tell us a little bit about what you do, what your products are, and why you think they're so good.
Okay. So my name is Edward Alves. I'm the sales director at Sinepower. Sinepower is a company that design, manufacture, and sell power electronics equipment. So that's our focus. We're very focused on power electronics, electrifying the world, as we've been discussing lately, and the theme is very important now, and everybody's discussing this. So we're on track with that, and we design and manufacture, as I was explaining, equipment, and specifically for airports. With concern to the ground power units that are supplying the aircrafts when they are in the parking space, right? And for hangars as well, for maintenance operation, for all those sorts of things. And we also do electrical car charges for electrical vehicles, be them the electrical vehicles that in the future will be in our airports, or for standard electrical vehicles or buses that are in the streets right now. Okay, so that's our main focus. We also work in the maritime and ports industry, so we're quite diversified in terms of different industries and markets, where we do the frequency converters up to 1 megawatt for, let's say, a European ship that travels to the United States and needs to be connected to electrical supply. They have to have a converter so that they can be supplied. So it's the same idea that you have on a ground power unit, but just for the naval part of the business. So.
Yeah, makes sense, and it's very logical. Now, Edward, what we're going to talk about today is three key areas. So the electrical ground power units themselves. So if you give us a little bit about that and why they're so important, and what the product offering is. Then we've got electrical ground power infrastructure, and I'm pretty sure you'll cover some of the shortfalls that are there, especially at airports. And finally, the electrical ground power solutions that you're able to table for any interested customers. So if we start the ground power unit, so you've explained the principle of what they are, and I'm sure, even if there are some people or relatives of people in this industry who might get the chance to hear the podcast, whenever an aircraft lands or takes off, it doesn't always use the power unit that's on the aircraft for obvious reasons, and it connects then to a ground power unit.
Correct, that's exactly it.
Exactly.
So the idea is that you don't want to keep your motors on. You want to turn them off, and you need a power supply that can supply the aircraft so that you can keep the electronics working, the air conditioning and such, right? So that passengers can come on, come off, or if it's cargo, you can remove your cargo and such, right? So that's what the ground power unit does. Traditionally, it started off as being a diesel supply, so basically a motor and an alternator supplying an aircraft, meaning that you didn't need any mains supply of energy, because basically it's diesel inside a motor, and that's what's supplying the aircraft, right?
Of course.
The issue with that is that these systems are super inefficient. They're like 30% efficient. So the same logic that you could use for the electrical vehicle, you could apply the same logic here, right? So the diesel GPUs, low efficiency, but very robust and very easy to use anywhere, right? You don't need a supply.
Correct.
If you want to jump into something slightly more, not slightly, but a lot more efficient, you'll go for a solid state, frequency converter solid state GPU, which you'll need a mains supply. So basically what you're doing, in fact, is connecting your aircraft to the mains, like you do with your cell phone.
Exactly.
We're talking about a bigger power thing, right? We're talking about much more power, and you need to convert the frequency from the mains to a specific frequency, which is 400 hertz in the case of aviation, and to supply the aircraft, right? And then there's now a third option that's not the solid state, but it's a battery-based GPU. Now, we can talk about all sorts of batteries and all different sort of philosophies behind the batteries, but the idea is basically You do not need a main supply because you have a battery and that will be your power source. Then you have an inverter that will give transform that DC into AC to supply the aircraft with the 400 hertz. So those are basically the three options that you have in terms of ground power units. Yeah. And that's how it's been structured now. What we're seeing what we believe also the future will be is to move into the battery-based systems, because once again, efficiency is much more. So you have like 90-something% efficiency. So if you're thinking about in terms, financially, let's talk about financial side first, and then we can look at the environmental side, and we can look at the operations side. Financially, you have a faster return on investment, okay, and you still hold an asset in case you buy the battery, because those batteries will, of course, lose autonomy, but they can be used as a second life battery, right? So they can be used in another purpose in the future, as a energy reserve or energy supply in the future, right?
So for people not too technically gifted, inclined, or interested, so when you say you can move from a primary battery source, after a period of time it loses a certain efficiency, but then because it's lost the efficiency, it's no longer clear to be used at that higher level, shall we say, and then it can drop down to be used for other.
Precisely. So that's the philosophy.
And then gradually it drops and it drops.
Precisely. So the philosophy that started with the electrical vehicle, so it's called second life. They call it second life battery. And we're reaching that point actually right now, because most of the electrical cars that were the first ones, the Leaves and the Renault Zoe, I believe, all those cars are reaching those 10, 15 years. And those batteries have lost, let's say, 30-40% of their autonomy. So what are we going to do with these vehicles? We're just going to throw them out and just disregard the battery. We need to get or we recycle those batteries, right? Or we can use them in a second life purpose, which would be to control and to stabilize the mains, or to use it as an additional supply with photovoltaic panels. So there's a lot of opportunities in terms of what that battery can become. And I think that's important to refer that, because most people I talk to do not understand, and they think that the battery will be thrown away and it's going to pollute and it's going to be worse. No, there are other options, other things we can do to resolve that issue. Doesn't take away from the fact that the batteries are super expensive and there's a lot of pollution associated to the way we manufacture them.
Yes.
That would be a second issue related to that, which would be the development in the batteries, right? What new philosophies, what new chemicals we'll be using in batteries in the future? I think that will take a little bit longer. And it's financially motivated, because people that have invested in the technology we have now for the batteries, they need to see their return on investment. Tesla is not going to come out with a new solution, different chemicals, whatever, until they get their return on investment on what they've done already in the batteries that exist now. So I believe that the second life battery option will be sustainable and will have a future, in my opinion, of course.
For some time, exactly. And as far as like when you talk second life and everything, and you're talking about batteries, what's your experience now on some of the fire authorities at airports who actually come up with a statement and say that they won't allow batteries to be on airports, when, ironically, there are some fire authorities who've got their own equipment with batteries.
Indeed.
But the authority, their regulators, or they're the ones who lay out the guidelines for the airports, that it's very misleading.
It is. It's misleading, and there's a lot of lack of standards. There's a lot of lack of definition of how this can move forward.
Yes, yeah.
And that's maybe one of the biggest downfall, not downfall per se, but it's one of the negative points of what's happening in terms of the electrification, right? Is that it's not clear to everybody what the standards will be, what's the best way to get the best efficiency, to get the safest solutions out there into the airports, right? So, in my opinion, I would start by standardizing first. But normally the markets have to push, so there has to be a push for standardization to come afterwards, because bureaucratic stuff is normally delayed, lagged in terms of what people want to do. So markets move faster, and then the bureaucracy and the standards appear. But
or an incident
generates a necessity for a standard or for some sort of health or safety document, right?
Exactly.
So I think that's definitely necessary, and I think now is the time for, especially because here we're also talking about different charging systems, different batteries. Now we need maybe to clarify what the range is, what can be done and what cannot be done, and start standardizing some things so that everybody's using more or less the same. That's already happening in the electrical vehicle standard cars, right? So in Europe we have CCS, we used to have Chademo, which were the first one of the Nissan Hyponic stuff, that's dropped now. So now we're going to CCS because the power demand is also growing. And then you have the Tesla option, so we'll see out of these two which will prevail in the future, right? In terms of safety-wise, in terms of the battery, for example, we've took 3 years developing a specific battery that we know has a lower energy density, but is much more safer. So the components, the chemical components that we're using is a LiFePO4 battery. So it's non-explosive. It does burn as any other battery will burn. Anything will burn, basically, right?
Especially that.
If there's oxygen around, easy, right? But this battery is specific because it's much less risk for anybody putting it in an airport. So if the battery is perforated, it might start burning, but we have a system that can inject contain the module. So we've taken a slower approach to this because we thought, well, the battery is the most important part of this, because inverters, I mean, 1,000 of them out there, and they're different topologies and whatnot, but you can get that relatively easily, right? The battery is where the magic is. So what you want to do is have a safe battery, and that's what we've taken a little bit longer to do that, right? So we're finalizing our product, and hopefully we'll start getting that product out and see some good results on that.
But there is a big fear, isn't there?
There is a big fear, and rightfully so. Yeah. I mean, you can look up videos on YouTube, and you'll see what happens if you perforate a lithium battery, right? Yeah. And it's quite scary. And there's actually some videos of battery GPUs burning in aircrafts, right?
Lots, too many, and that doesn't do anybody's image very good.
Yeah, exactly.
And as far as people doing their risk assessments, worst case scenarios, you got your image. What does it say to your customers and everything if they see it, even if they don't understand it.
Indeed.
So that's a big issue.
It is.
But I can imagine IATA coming out with a little bit like the LAR and the other specialist manuals, they're going to have to come out with battery sensitive regulations or something.
I think so, for sure.
And I think it's going to be quite a substantial manual.
I believe so.
Yeah, but it makes a lot of sense. Right, so that's good. Now, with all of that in mind, so we got a little bit of challenge from the fire authorities. We got a little bit of unrealistic acceptance of commitment or engagement from airports. Mm-hmm. So you have to face all of that.
I do, indeed.
You have to deal with all of that, and then you have to decide how do you best leverage, influence, etc. Where do you think there are opportunities now for, especially for the infrastructure issues, and why do you think there's a bit of, maybe I'm wrong, okay, and I said at the conference I'm definitely not the brightest bulb in the chandelier, but what I see, I say, and I think there's a huge amount of misunderstanding and miscalculation from the people who should be taking a lot more responsibility and influence in the outcome. Indeed.
There's a very big, there's a main issue, and that's been actually something that's conference after conference. So I've been participating in these ramps and ops conferences since 2014, if I'm not mistaken.
Yep.
And in the conferences, we always have the same issue. So on one side, we have our handlers, we have the airlines, and on the other side, we have the airports, right? Of course, the airlines and the handlers, they want to go to the most efficient, the cheapest, and the fastest return on investment equipment. And that's where electrical looks quite good, right?
Yeah.
But they need, of course, a physical infrastructure, electrical physical infrastructure to charge the batteries, to supply electricity to the equipment. And that would normally be, or you would think it would be, responsibility of the airports, right? But some airports believe it's not their responsibility. So sometimes we see a clash between these two entities to get the to see who has to do the infrastructure. Because whether we like it or not, if we want to electrify our cities, our airports, whatever, we're going to need infrastructure. That means a lot of copper, that means a lot of aluminum, a lot of metal, and we're going to have to change the cables, the transformers. That's all going to have to be much bigger. And then there's also another issue, which is how can we foresee the power demand, and how can we prepare now for the next 20, 30, 40 years, whatever, right? So that's also a very big issue that it's not there's no easy solution for that. I don't want to go political, but I think eventually the governments or somebody will have to impose some rules and say, well, if you're the airport owner, you will have to do the infrastructure, and you have to supply an infrastructure that is capable of handling your power demand, so that handlers can opt between the diesel or the electrical options, right?
100%. And you said something there. You said about how do they foresee, what's necessary, and it's ironic because I work with some guys, and we do this as far as training and change program for them. We have a 4C concept, which is clarity, competence, compliance, and control. And more often than not, if something goes wrong, so whenever we do a validation or a business sustainability review, it comes back to the fact that the clarity wasn't there right at the very beginning.
Indeed.
And if that's not there, you're misguided with the level of competence you need to have compliance. And if you have compliance failures, you don't have control. And I think that's going to be so necessary. And now, as an engineer yourself, okay, if I was to put 5 products or 4 products on a shelf, and they were all manufactured or produced in certain different areas, you'd know which ones you would buy and which ones you wouldn't.
Correct.
And the reasons why.
Correct.
So now, when that comes back to clarity, why on earth is that not made more transparent? Because if it was, then the three step, what I call nasty purchasing, which is cheap, fast, and easy, there wouldn't be so much of it.
No.
And my grandfather once said to me, "Buy expensive, you cry once. Buy cheap, you cry every time."
Indeed.
And I think a lot more reality needs to be made as to what the impact is of what we actually do in the beginning.
Mm-hmm. As you said, clarity. We need clarity, and we don't have that clarity yet.
Yeah.
I mean, there are ways of moving this. I mean, the manufacturers can work very closely with the airports, with the ground handlers to have an understanding of what their power demands are, their operations are, and try to give them solutions that have longevity. But as you said, that's expensive, right?
Yeah.
And especially in European countries, in the States and such on. So if we're looking for something, a cheap, quick, fast solution, that doesn't exist. I mean, or it can exist, but it's not going to be beneficial in the long run.
And it becomes a tick box on the green sheet.
Precisely. Yeah.
And then people are not aware enough, which is a terrible thing.
You can tick your green box and be all happy and show your shareholders, but then the operation is not going to be fluid. You're going to have issues down the line, and that's all going to come up to the shareholders anyway. So why not do it properly from the beginning, or at least try to have a clear and defined path to do it? Exactly,
100%. Now, we're running a bit short on time, and I don't want to keep you longer than is necessary, because I'm sure you've got to go and put some oil or you've got to do some sort of
blow dry my beard.
Yeah. So let me ask you, just to finalise, Edward, 3 critical actions that if you were able to wave a magic wand and you would say, look, if everybody listened to me and if everybody took my technical and my engineering background into account, these are the 3 critical things that we should be doing.
Yeah, so basically I think there are 3 critical things that we can do. So it's the lobbying on the governmental side for the implementation and the standardization, so that we can all have clarity, basically, or at least some degree of clarity. So that would, for me, would be number 1 without a doubt. And then we have to start thinking about, as I was saying, foreseeing the future. So what's the next step? We need people that have the proper training to move from the diesel-based systems that we have now into the electrical, because it's a different world. It's not the mechanical world. We're talking about the electrical stuff. We're talking about batteries, rectifiers, IGBTs,
and it's a huge difference, isn't it?
It's an enormous difference, and the training is different as well, right? So I'm not saying that these people cannot do it. Of course they can, but they need the training to be prepared for this change, right?
Yeah, so but you've also got the people issue, haven't you? Because today I'm a diesel expert and I'm a traditional legacy engineer. Mm-hmm. Tomorrow, something new again.
Precisely.
Bit of pressure, bit of stress again on the individuals, bit of fear. Can I do it? Will I do it?
That would be my 3rd point, which is the inertia, and trying to break the inertia. So giving the information to the people, giving the training to the people, helping out in that aspect, I think is very important if we want to be successful with implementation of electrical systems in the airports and the rest of the cities or whatever. Right?
Yeah, no, brilliant. So what you've actually done there, you put lobbying on the government side for clarity. Mm-hmm. Then you've also put foreseeing the future with, from diesel to electrical, helping people train in and become better, which is the competence, which I said. Then you're looking at the inertia in the right way.
And, of course, the 4th one would be the infrastructure that we've already talked about before. Right?
Exactly. So what we've actually done there is we've fulfilled the 4 C's, because we've gone from clarity to competence to compliance.
Perfect.
And obviously, if you've got the right infrastructure, you've got control.
Correct. It seems like we're on the right track.
So we've met in the middle, my friend, and I'm sure we'll meet again. And definitely this evening, it'll be an absolute pleasure to see you at the function tonight.
Thank you very much for the opportunity.
Thank you for your time, and thank you for you allowing me to make reference to, honest to God, there's some things you'd like to do in life, and I'm not the youngest, so I should be able to grow a decent beard. But if I could grow one of them, I'd love to do it without telling my son, because he can grow a great one.
You should then.
Yeah, no, you can. Listen,
you
thanks very much. Good luck
Pleasure.
with everything.
Thank you
It's been
very
an
much.
absolute pleasure talking to you.
Thank you very much.
Cheers.